Professor Jain, I think that we can start now.
Okay.
Yeah.
Give me just 1 minute.
Yeah, whenever you are available. So.
Leon, can you give me the screen control again? Sorry.
Give me a second. Oh, I'm sorry.
Yeah, no, because I logged out and so I lost.
Oh, I see. Okay.
Okay. I think we're ready now.
Yes, go ahead. Yeah.
Okay, can everybody hear me okay? Perfect.
Yes.
Okay. Okay, well, thanks for coming to the seminar this morning. And it is pleasure to get involved with this important NSF project. Just a little bit of introduction of myself. I'm Hemant Jain, Max Finley Chair in business, mainly focusing on data analytics. So I work in the area of business analytics, text mining, machine learning, big data management. I moved to UTC about 4 years ago, so it has been already 4 years. And before this, I was in University of Wisconsin, Milwaukee, for about 33 years in the College of Business there, mostly focusing on different IT issues. So this is my website in the college, so you can get more information from that if you like. So let me just start the presentation. Feel free to stop me, raise questions anytime. I'm going to hold on 1 second. No? Okay, so I'm assuming you all see my single screen here. So the today's talk focuses on the identifying the implicit online communities. So we focus on online communities, and specifically we focus on Twitter and how healthcare professionals engage in Twitter and share the knowledge in that area. So this is a joint work with two of my PhD students who are now they graduated, both of them, and they are now at University of Texas at Arlington. Obviously, it's a jointly, we worked over a number of years on this one. So let me move to the next. Oops. I'm having a little bit of a difficulty here. Moving to the next slide. The presentation part is not moving. Sorry, a little bit of an issue here. Don't know why. This thing is not moving.
Okay.
Let me restart the thing. So I don't know why the presentation wasn't moving properly. Too many screens open. Okay. The agenda today is that we will kind of start with the context of the problem and then give you some background literature, talk about some theoretical background. So this work is a little bit different than what you will see in a computer science typical field. It uses a lot of psychology and social sciences methodology. So you'll find a little bit of a different flavor here. And then we will focus on how do we go about discovering the structure of these online communities, and then how we collected the data and analyzed the data, and then talk about the impact of the position of individuals in these communities on how they share knowledge in these communities. And hopefully we'll have enough time for questions and discussions. So the context of the problem is implicit online communities. So in social networks, and as you all know, the social networks are becoming increasingly important. They are actually having major impacts on our lives today. Many users of social networks today. And the leading platforms for the social networks are today Facebook and Twitter. So the online communities are basically the fluid boundaries. They are generally based on expertise. The authority people get in these communities are based on their expertise, their participation in that, and they get the emergent role in that. So there are actually two types of online communities. One is what typically known as explicit online communities. So these are explicitly developed to focus on a specific field of knowledge or specific issues. So maybe an online community dedicated to the COVID-19 or to cardiologists or to a particular field. And they are organized for that explicit purpose. The members are all interested in that, and then they share knowledge in these communities. And they are well established, and fair amount of work has been done in those. But the area we are interested in is these implicit online communities. So these implicit communities are not explicitly created. Nobody actually creates and controls these communities. And they use platforms like Twitter and Facebook to build on them. And so they just get implicitly built on these platforms. So the structure of these communities, implicit communities, have an impact on how people interact between them. And that is the area of our interest, is what is the structure of these implicit communities that get formed, and then how that structure impacts how people share knowledge in these communities. So obviously these implicit communities are increasingly becoming important because they create value, because a lot of knowledge sharing happens in these implicit communities, and a lot of important information actually gets shared in there. And they obviously are also helpful for the success of the platform itself, because it increases the user engagement in the platform, and platform makes more money, like Twitter and Facebook. So obviously they're already doing very well. So the background literature we draw from for this work is in the area of consumer participation and the producers of the information. So one of the factors is that what is the motivational factors for people to contribute to these online communities? Why do the people spend huge amount of time and resources and contribute for free most of the time, not getting any money, important knowledge, important information in these communities? And fair amount of work has been done in the literature drawing from the motivational theory in this area. And few of the important factors which motivate people to spend a lot of time and contribute a lot of important knowledge and information in these communities is the reputation in their community. So people build their reputation in these communities, and that is very important. So even though it is not monetary benefit, but it is very satisfying for these people. And so that is a very big motivating factor, is how is your reputation in these online communities. The second motivating factor is reciprocity, is that if I contribute to these communities, somebody else will contribute to that. And kind of the same principles works on the open source community. As you know, the open source software, people spend tremendous amount of time and resources, contribute a lot with basically no monetary benefit, no money benefit. The third motivating factors which people found motivate people to contribute to these communities is the sense of identification. So they identify themselves with this community, they belong to this community, and humans have a need for identifying with a group, with some movement. And so that is another thing. And last but not least is the enjoyment. They enjoy it, they like it, that's why they do it. So it's not for money, it's not for something else, but they just enjoy contributing, they just enjoy sharing, they enjoy the reputation they get, they enjoy the knowledge they get from these communities, and so on and so forth. So that's the kind of background literature we draw from. So one of the key thing which we are interested in studying is the user engagement in these communities. So the user engagement is defined as the psychological state or behavioral activity. So basically there are two parts to the user engagement. So they are psychologically involved in these communities, and what is their behavioral activity in this community, how they behave, how much they log on, how much they contribute, how much they read. Those are all their behavioral activities. So most of the research in that area, user engagement area, which has been done is based on the exogenous determinants, like the self-reported data. So most of them uses the survey data, they uses the survey of these people, collect the data, ask them why they're contributing it, what is the motivating them, and so on and so forth. However, we are going in a little bit of a different direction. And what we are really focusing on is to look at the role of the network structure. So what is this network structure of these communities and how that determine their contribution to this community. So, so this network structure actually determines or generates what is typically known as social capital. So a social capital is really, it's not money, but it is really your social reputation in the community. That is the capital, social capital you built in. And what has been found is that certain position in the network determines how much social capital you built in this community. And again, a lot of this research has been focused mostly on the explicit communities. And our work actually focuses on the implicit communities where not much work has been done. So basically, in our work, we focus on identifying the implicit communities because that itself is a major issue. Because these are not explicitly there, there are no members, there are no explicit memberships or anything. They just get implicitly formed. So how do we go and find or identify what are these implicit communities? And so detecting these communities is where we focus a lot of work here. And then after we identify these communities, then we study the user engagement in these communities. So we consider both psychological and behavioral components and apply the network theory and the social capital theory to study the user engagement, how user engage in these, what knowledge they're sharing, how they're sharing. And the second part is still work in progress. So we're still working on that. We still have a fair amount of work to do in the second part. So the key research questions we're trying to answer here is how can we capture implicit health communities within public online social networks? So first is how do we identify or we can capture these implicit communities specifically focused on health area within a public network like Twitter. And second question we're trying to answer is how different attributes of these implicit health communities impact the health professionals' efforts in generating the content in these communities, the content of this community, the postings on these communities. How these different attributes of these communities, the structure, the network structures and other things impact the content generation. So that's kind of the focus. Any questions on that at this point? Any clarifications, anything? Okay, so let me move forward. So as we said, the theory we really base our work on is the social capital theory. And a social capital basically is defined as an investment in social relations with expected return. So basically this social capital you built is basically you make investment, not again monetary investment, but investment in other kind to build your social capital, you build your society, you build your relationships in the society. Researchers have identified 3 dimensions of this social capital. The structural dimensions, which is the structure of the society, the relational dimensions, how they relate to each other, and the cognitive dimensions. And each of these dimensions has their own constructs. So the reference model which we are using as a theoretical background is the model by Chu 2006, which was developed. And in this model, the social interaction, the structural dimensions is basically how they socially interact with each other, or the interaction ties. The relational dimensions consist of three factors: trust, norm of reciprocity. What is the norm in the society of reciprocating? So if you make post, you will get an answer to it, you'll get a response to it. That is the reciprocity. And the sense of identification with the community, belongingness with the community. So those three are measured of the relational dimensions of the. And the cognitive dimensions is the shared language, whether all the members of the community share a common language. And when we talk about language, we're really not meaning the English or Chinese, we are meaning the language of that discipline, language of that interest. So if we are talking about the a medical cardiology social community, whether all of them share the same cardiology language, and whether they all have the shared vision. And so then these factors contribute to the quantity of the knowledge shared in these communities and the quality of the knowledge shared. And obviously these two outcome variables are impacted by the personal outcome expectations of their members and the community related outcome expectations. So that's kind of the reference model we use in our work. And we adopt that reference model to develop our own structural model or our own research model. And again, this is a little complicated, but I will kind of broadly go through that at a high level. So related to the structural, relational, and cognitive dimensions, we use the structural dimension in implicit community and measure it based by the centrality factors and the strength of the ties or the strength of the relationship. So the centrality factor is how central is the person's position in the community and what is the strength of their ties with the other members of the community or the relationships. The relational dimensions measures through trust, norm of reciprocity, and the identification, which is the same as given by Chu. And the cognitive dimensions are measured by these 6 factors: ratio of centrality to implicit communities, ratio of strength of ties, ratio of norm of reciprocity, trust, and so on. And we measure our outcome through the user-generated content. How much user-generated content is developed in the community? So in the case of Twitter's, it's measured by the number of messages posted, and so on and so forth. And we measure that by the quantity of the user-generated content, readability of those content, comprehensiveness of the content, and the relatedness of the content. So that is not only just the count of the content of the messages, but how good those messages are, how useful those messages are, and so on. So as we said earlier, the focus of our study is on Twitter, and specifically we focus on the healthcare professionals. And the reason we focus on the healthcare professionals is that healthcare is one of the prominent area of information seeking and sharing on the internet now. It's increasingly becoming popular. And obviously with the COVID, healthcare has become even more prominent in terms of sharing information, getting information. 60% of the American adults searched healthcare related information on the internet. Healthcare professionals should participate in the health information diffusion process. So the key people have been making argument is that the participation by the healthcare professionals in these communities is extremely important because they can provide the correct knowledge and correct the knowledge in these communities. And so I think that is of increasing interest is what motivates the healthcare professionals who are already very, very busy to participate in these communities and share their So the social media has a great potential in providing this new communication media specifically for the public health information. And that has obviously become increasingly important with this COVID crisis here. So the way we collected the data is we used the Twitter API to collect the data about the healthcare professionals and people interested in the medical information on Twitter. So the Twitter API is that one of the issue with them is that do not provide a method for data collection related to a specific domain. So they don't really identify the domain of the users and allow you to collect the information on just somewhat or certain domain. So they don't have this domain defined. So we adopted a modified framework, which was proposed by Xu and Xu to create a novel mechanism for collecting the data related to the medical domain. So we created a general boundary around a desired population. So we are interested in this. So Twitter obviously has 200 million accounts and a lot of users, which we could not go through obviously. So we are interested obviously is this desired population of healthcare professionals or people who are interested in this healthcare. And so we developed a mechanism to identify these people in the Twitter community. And so we used actually started as a starting point, the US News and World Report's best US hospital ranking as a starting point to start identifying people who are interested in healthcare or who are healthcare professionals on Twitter. So this is our overall framework for data collection for identifying the implicit communities. So in the first step, what we did is we selected the best possible initial set to start from. And we thought the best possible set is to start from the top 30 hospitals and clinics which are ranked by the US News and World Report. So we started with those 30 accounts of these top 30 hospitals and clinic accounts on Twitter. And then we looked at all the followers of those 30 accounts. And we found about 1.2 million follower accounts. So find the followers of this initial set. So we got 1.2 million accounts which are following these 30 accounts, which indicates that these people are interested in the healthcare area and they are following these top 30 hospitals and Twitter accounts. Then in the third step, we filtered these accounts. So users that follow at least 2 healthcare professional accounts, because if they were just following one, incidentally, maybe for some other reason, so we didn't want to focus on them, and we needed to reduce the number anyway. So we kind of decided that we will only focus on people who are following at least 2 of these 30 accounts. And that ended up with about 157,912 accounts. And so we then used these accounts and analyzed those to find the network structure. So we'll talk a little bit more details on that here, how we do. So the way we collected the data was, we looked at these user accounts of the health professionals, 157,912, such as hospitals, doctors, nurses, health journals, and medical students. All of them were included in that. Some of them also were health consumers accounts who follow these health-related accounts because they have interest in the health information. They may not be health professional, they are not the experts, but they have interest in this health. And so then we use the Twitter account profile. So there is certain information in the account profile, people generally provide that. So we use that information and then used a predictive text mining approach to classify these accounts into whether they are actually health professionals or health consumers. Because we were actually interested in only health professionals because they are the one whose knowledge we are interested in contributing. The users are more interested in getting the health information, not as much contributing the information. So to train our machine learning algorithm, what we did is we selected randomly 3,000 accounts from these 157,000 accounts to create our training data set. And then we manually labeled each of these 3,000 accounts. So basically we looked at the profiles of these 3,000 accounts and manually classified them as healthcare professionals or healthcare consumers. Okay. And so out of these 3,000, we classified 897 as healthcare professionals and 2,103 as healthcare consumers. And then we used this training data to train 6 machine learning algorithms to do this for us for all of the 157,000. That was the whole reason for developing this machine learning algorithm, so we don't have to manually go through these 157,000 accounts and classify them. We could use the machine learning. So we trained 6 machine learning algorithms: SVM, support vector machine, maximum entropy, boosting, neural network, SLDA, and decision tree. And then we found the average F measures across all the 10-fold cross-validation to evaluate each of these algorithms' performance. And this was our result. So we basically calculated the accuracy, calculated precision, recall, and the F1 value. And the SVM was the top performer in terms of accuracy, precision, recall, and even F1 value with a very close follow-up of decision tree. So we selected the SVM to classify our accounts. And so after running these 157,000 accounts through the SVM, we classified 34,583 accounts as the healthcare professionals account. And rest of the accounts were the healthcare consumer accounts. So then the next phase was, once we got now these accounts of the healthcare professionals, we were interested in looking at the network structure among these healthcare professional accounts. So how these communities get formed within these accounts, that's what we were interested in finding out. So we were interested in exploring the network structure of these accounts, which we just identified. And so we collected the tweets for 6 months from all of these accounts, which was basically 34,583 accounts. We removed the users who did not post any tweet in this time 6 months period. And we ended up with about 44.7 million tweets from 22,000 users who posted the tweets in this 6-month period. Then we use the follower relationships between these professionals. So in Twitter, you can follow people, obviously. So we looked at those follower relationships and developed our network. So our network contained these 22,854 nodes with 3 million directed links. So it was a huge network. And to kind of simplify the network, we removed the unidirectional links and so only kept the links which are both directions, bidirectional, and ended up with about 400,000 links. And so now we got this network with 22,000 nodes with 400,000 links, and then we use the community detection algorithms on this network. So the way the community detection algorithm works is that it looks at a modularity index, which is a well-known measure that can be used as an objective function in community detection. So what the idea was that out of this 22,000, we wanted to see what different communities are developed inside, and we wanted to detect those communities. So we use this modularity evaluation. It basically evaluates the number within the community ages relative to the expected value of the same quantity in a random graph. So basically, we are looking at the relationships which are tightly related to each other, these accounts through the relationships through the modularity index. So the goal of this modularity-based community detection algorithm is to maximize this modularity index. And what generally is that a value between 0.3 and 0.7 is considered to be a good indicator of clustering. So it is really similar to a clustering method where you're kind of trying to identify clusters. Okay. So we used actually this Lowian community detection algorithm, and we applied this method at 2 hierarchical levels. The algorithm divided, so the first time when we ran it, our algorithm divided these 22,000 accounts into 45 clusters with a modularity value of 0.43. The 17 clusters of these 45 had fewer than 4 nodes. And so that was too small a community of interest to us. So we removed those. So we dropped those which had fewer than 4 nodes. And so we ended up with about 28 communities with a total of 22,817 members. So this is the high-level community network. These are the circles here are these 28 community nodes represented. So then we basically started looking at details of each of these communities and the structure of that. And so we found this structure of these communities quite different, which is very interesting. So some community had this kind of a network structure. Some communities had this kind of a network structure. And this is their modularity value. So the community which the right kind of structure, the right structure are actually, you can see that they are splittable communities. You can clearly see that these communities can be split into 3 or 4 communities. Okay. So we basically went and reapplied this community algorithm for splitting this again. So we started splitting these communities which are splittable. So at the second level, we applied the Lowian algorithm again to each of these 28 communities. The modularity index of this second level community was in the range of 0.24 to 63, and a value of 0.3 was considered the threshold value. And we ended up with about, after splitting these splittable communities, 111 communities from these 28,000. So these implicit communities which we identified had different structures and functional patterns. And then we started doing the content analysis of these healthcare professionals profile. So we kind of just looked at what are the type of people in these communities, just kind of to figure out how they are formed, which was quite interesting to find. So what we found is that similarity in the social categories is the dominant element. So the dominant element which brought them together is their similarities in the social categories. Out of 111 implicit communities identified, 18 communities were based on shared interest and skills. So they were formed because they all shared the same interest and same skills. Right? A interest in particular disease or some particular skill or surgery or something, some shared interest there. It confirms the Durkheim's observations that the modern communities are formed around similar skills and interests. So basically, people form these implicit communities based on their similarities in interest in skills. So the 16 communities in this network were formed based on the geographic proximity. So they were actually geographically close to each other. Based on the profile, we found that they were based on the geographic proximity. The others were based on the similarity in their interest. So we kind of named these communities as of two types: identity-based community. So for example, one of the community had this kind of a structure, and by looking at the profile, these people were interested in the orthopedics, and so it was an interest-based community based on orthopedics. So these were orthopedic surgeons, other nurses, physical therapists, and so on and so forth, who were interested in that. A location-based community was something like this: a Colorado State Health Professionals community, which was more of a location-based. Colorado, these were the people in Colorado who were interested in the health professionals in Colorado. So it was more of a location-based community. Another kind of community we identified was the common bond communities. And these communities has a unique structure, star-shaped structural topology, in which one or several members connect to most of them. And this was a very interesting pattern we found. So in this case, there is one or few very prominent member in the community. Everybody follows them. And the members do not attach to each other, but they all attach to this one or two members. And 14 communities were of this type, and this was their structure. So there was this central important one member, everybody was following this one member, and the others kind of just attached. Similarly here, there were 2 or 3 important members, everybody was following them, and so on. So in terms of our measurement model, we measured the dependent variable was our user-generated content, we talked about earlier, which is the quantity of health-related tweets over the 6-month period. And we developed a filtering method to separate the health-related tweets, because in these communities, there are tweets, but some of the tweets were not related to health. They were just general other tweets. And we didn't want to count those, so we needed to separate. So to do that, again, we used a NLM MetaMap, which is developed by the Universal Medical Library, which basically is a library of medical terminologies. So we used that, and we basically did the text mining on these 4 million tweets, and we identified about 2.9 million tweets were considered health-related because they used one of the terms from this UMLS library. Okay. So basically, from this UMLS library, we extracted the semantic groups based on these terms. So actually, UMLS library identified these semantic types, and then from their semantic groups. So you could actually identify what is the focus of this group is, or what is the focus of these tweets are. So these semantic types groups into a group called disorders. These groups into a group called procedures. These groups into a group called chemical and drugs. These groups into anatomy, and these groups into a physiology group. So we use that. So the measurement model, we also measured the explanatory variable centrality, because that was one of our input variable, if you think about that. So we measured the degree of centrality of this community, captured by the connectedness of the person. Betweenness captures how important the individuals are in connecting with each other. We measured the closeness, and then we compute for each of the individuals in these communities, those measures. So this is the formula for the centrality measures, and so I'm not going to go into the detail of the formula, but just to show you that. So the explanatory variables is the again we measure the structural topology by the degree of distribution capture the members' attachment to the community. We also use certain control variables which is the age of the accounts, it's how old the account is on Twitter, number of followers that account has, and number of friends that account has. So we use those as a control variables to kind of identify the effects with anything. So we conducted the empirical analysis to analyze the association between the structure of the community, individuals' position within the community, and the information behavior, sharing behavior of the. So basically the idea is to determine the impact the structure and the position of the person has in their sharing behavior. For that, we use the regression analysis, negative binomial, and these are the results for that. So a lot of the variables were significant, all with 3 stars. So this was the network topology, was negatively related, network centrality, high degree of centrality, has a high relationships here. So in terms of the results, what we found was the member centrality in these implicit online communities has a positive association with the participation level. So what that means is that more central this member is in the community, it impacts their participation level. More they are going to participate. And this was supported very well in our analysis. The second hypothesis which was supported was that the structural topology of an implicit online community has a positive association with the participation of members in the social media platform. So this again was supported. So the structure of the community impacted their participation, how the community was structured. So the results indicate that an increase in power law exponent, so which is the lower level of connectedness in the implicit communities, decreases the level of member information. So if a member is connected to the community at a low level, not very well connected, then they participate less, they share less information. That is what we found. So the contribution of this research, how structural capital in implicit communities plays role in engagement of individuals in the social media. We developed a novel data collection approach. We identified implicit communities and their structures. We found a strong association with their sharing behavior. We differentiated between the implicit and explicit communities, which was not done as much before. And we explained how this structure is associated with the involvement of the people in the community. So the structure of a community can develop a sense of community among the members. We find that individuals' level of information sharing in the bond-based implicit communities with a few highly connected and many weakly connected members is lower than the identity-based community. So if it is a bond-based community where few individuals are important, the others are just observers, others are not contributing as much knowledge. But this one central individual is contributing most of the knowledge. So based on the results, similar areas of expertise, common locations, and personal attractions are the 3 major reasons why for forming these implicit online communities. So the implications of this work, the organizations can increase the level of interactions among the members of the community by conducting various events or seminars. This will allow them to convert a simple bond-based community to a complex identity-based community. So organizations can push people to convert a bond-based community where they're just following one person to more by conducting seminars, more interaction, more groups, to have more people active. Companies should concentrate on central members of communities as they can help in terms of providing free content and attracting other customers. Managers of these social media platforms can identify different implicit communities and offer additional tools to them, so their platform use can increase. And they can also provide some incentives to the core members of this community. So this is, again, as I said, is still a work in progress. We captured only the non-overlapping implicit communities right now. So we did not capture really if a member is member of 2 or 3 or 4 implicit communities. We did not capture that. That is something we need to do. In the future, we collect more tweets from these communities and do a deeper content analysis on the tweets. So that's kind of what. Questions, comments? Any questions?
Please unmute yourself. Yeah, go ahead. Question time now.
Yeah, go ahead. You are on mute. You need to mute. Unmute. Yeah, go ahead. Say it.
Yes, one of your slides, when you mentioned the number that you find, I think 157,913, there is the 3,000. Is that 3,000 or 30,000?
No, so what we did is we basically, out of the 150-some thousand accounts which we identified as the healthcare accounts, we selected randomly 3,000 accounts and then manually classified them to create the test data set.
Yeah,
so it was 3,000, not 30,000, because to manually do 30,000 is too much work.
Oh, because
so we manually did only 3,000 accounts.
Yeah, I saw this is you split it for training and
for training set, yes, for machine learning algorithm training set.
Yeah, that's less than 2%. Is that correct? Usually, in that division, you divide by 80 to 20% or something like that. That's what's throwing me off. But you are using this 3,000 to start with, right?
Yeah, to train our machine learning algorithm. Basically, we use this 3,000 to train the algorithm.
Okay, thanks.
Yeah. Yeah, Dai.
I have a question.
Yes.
I noticed that you use profile to identify specific accounts. In Twitter, users can feel free to give the information in their profile. For example, I can give fake information.
True.
In the profile. Could it be a concern that this kind of behavior may mislead you or create
I think we are aware of that, and I think there are few cases where you will find the profile is not complete or doesn't have the correct information. But by and large, what we found is, I think a very large percentage of the people do provide reasonably good information in their profile. Okay, but yeah, there are outliers, definitely. That point is well taken, but that's a limitation. There isn't really too much we can do about it, because so even if 90% profiles are good, that's what we have to deal with. So, but we know that that's a limitation. There's nothing we can do about it. But that's a good point. Very good point. Yeah.
I have another question about a method mentioned on your slide. One method you used is called maximum entropy. Could you give me more details about this method? How do you apply it in the tweet analysis by using maximum entropy?
No, so the maximum entropy basically is the machine learning methodology we use for basically classification.
Okay.
So we basically use that to develop a classifier using machine learning. So basically our idea is to classify these accounts as the healthcare professionals versus healthcare consumer. Okay. So that is what really we wanted to do with using machine learning, was we manually kind of coded these 3,000 accounts by looking manually at the profile of these 3,000 accounts. And then use that to then train the machine learning algorithm. And maximum entropy is basically the variation of the decision tree algorithm.
Okay. Another question is, in your slides, I can see different methods may have different performances.
Mm-hmm.
Have you ever tried to use ensemble to put these methods together for achieving better performance?
Yeah, that's something we should have done that. Yeah, that's something we're going to do that. You're right, absolutely, because that might give a better method. Absolutely, I do that in my classes, but I haven't done that here. I cover ensemble in my classes, but I don't do that here. You're right. Good point. Very good point.
Thank you.
Mm-hmm. Other questions?
Yeah, I have a question.
Yeah.
Yeah, in the networks, you showed the visualization of the people, I mean the community. So you can see there are different edges between Twitter accounts. Different edges have different length. So is there any specific meaning represented by the length of different edges? The length represents, for example, the number of tweets between two accounts.
Yeah, I don't believe, and again, I have to check with my co-author. I don't exactly remember, but I don't believe the length represents anything. I think the width represents the kind of the thickness of this the line represents the depth of the relationship or the intensity of the relationships. But I do not believe the length represent anything. So the length was just a kind of the way it was drawn, the network was drawn. But I need to confirm that, but I think that's the way I remember it.
Yeah. I see. Thank you.
Mm-hmm. Other questions?
Hi, this is Jain from the School of from the Howard University. I mean, it was a very interesting presentation, and thank you for sharing that. Just I have a comment that I was feeling that it might be interesting to look at the difference between the, you mentioned that there are, you found two different types of community, one that is based on the location, and that the other one is more based on the, I guess like a disease or the
expertise.
Yeah. So it might be interesting to look at the differences in the structural characteristic between these two types of communities, like something like a network density, the structure of the communication interaction that happen within the community, and see see how the communication it happened differently, how the information spreads differently in these two types of community. And then another comment that I have is as you already have this work, it might be also interesting to look at how the COVID-19 related information spreads among the healthcare providers, because I think that's something that we are experiencing right now. Thank you for sharing the interesting work. Yeah.
No, I think absolutely right. This is a very rich area, and I'm more than happy to collaborate with anybody who's working with this kind of interested in that. But you are absolutely right. We can dig a lot deeper into these communities and study the behavior of the people, how the structure impacts it, so one of the area I am much more interested in is actually deep dive into these tweets themselves and really try to understand the kind of knowledge they are sharing. What are they actually sharing? What kind of information they are sharing? And is that information useful or not, kind of thing. So obviously that requires a lot more deep dive into the tweets itself, text analytics of these tweets, trying to figure out the concepts of the tweets, what actually they are sharing. So that's kind of the direction we want to move further. And I think because it is a very important media for sharing information, especially with the COVID kind of situations, it can be a very useful media to propagate and share useful information. Obviously, we need to be always watchful about the incorrect information being shared and rumors being spread. But that's the another issue there.
Thank you.
Other questions?
Oh, any questions? I think it's good. Yeah, I think I believe the audience are happy about your talk. Very,
Okay.
yeah, very constructive, very helpful.
Well,
Okay.
Thank you for coming. Wonderful.
Thank you for sharing this. Prof.
Thank you.
Yeah. Okay. I'm going to post the Dr. Jain's talk on the on the YouTube so that the student who miss it can can take a look, can watch it. So and if you guys are available, I will meet you guys 1 p.m. Yeah. This
Okay.
afternoon. Yeah.
Thanks everyone. Bye.
Thank you.
Thank you.
Bye.
Bye. Thank you, Dr. Jain.